Welcome, everybody. And topic 6, practicing questions and unit 2 and chemistry. I just want to let you know that this paper or this sheet, you can download it from the description box below. And we're going to start solving the MCQ questions first, and then we'll move to the free response question. The first question says, the enthalpy level diagram for a reaction is shown, as you can see, which is represented by this diagram. Just keep in mind, if you look at this diagram in here, you have to determine whether this reaction is endothermic or exothermic. And based on our knowledge, since the product has amount of energy less than the reactant, we can just determine that this reaction is an exothermic reaction. Now, we're going to look at these possible answers, which of these represent the exothermic reaction, and then it's going to be the answer. Let's start with the first one. A says Na solid to Na gas. This represents the atomization process, in which we are changing the atoms in the solid state to gaseous state like this. And if you have a logical thinking, you can notice that breaking the bonds between the sodium atoms requires energy, and that's why definitely A is an endothermic, so we exclude A as an answer. Let's jump to B. B represents something we talked and covered in Unit 1, which is the ionization energy. And if you remember the definition of ionization energy, it's the amount of energy required to remove an electron from the outer shell of an atom. And from here, since we say energy required, it determines that this reaction sure is an endothermic. It requires energy. So we exclude B also from our answer. Let's jump to D in here. Ammonium nitrate, if it dissolves in water, it gives you endothermic reaction. And just keep in mind, you have to memorize this point. For example, an AOH, if it dissolves in water, it leads to increase the temperature. Ammonium nitrate, if it dissolves in water, it leads to drop in temperature. And finally, let's go to C. You have, as we noticed, that we have two chlorine atoms and then finally bonded to each other. So we can notice that this is a bond forming process. And the bond forming process, definitely it's an exothermic. Based on that, the answer is C. Let's start with question 2. Question 2 says the energy profile for a reaction is shown. What is the minimum energy needed for this reaction to occur? Just keep in mind this definition here is for the activation energy. And the activation energy is defined as the minimum amount of energy required for the reaction to occur or to take place. It extends from reactant to the top right here. The answer is X, since it represents the activation energy. Now let's jump to question 3. An enthalpy level diagram for reaction with an intermediate is shown. Which arrows shows the enthalpy change for this reaction? It needs delta H, and delta H represents between products and reactants. So we have to find where do we have products and reactants. If you look at here, this is your reactant and this is your product. So the difference between them represent the answer, which is delta H. And definitely you can notice that A here represents the difference between products and reactants. And here is the answer. Just keep in mind extra information about this graph, if it just for extra knowledge. This graph represents a chemical reaction with two steps, since we have two tops in here. This is for step 1 and this is for step 2. And if I ask you, generally speaking, which of these two reactions is faster than the other, just keep in mind the one with higher activation energy, it will make the reaction very slow. So just keep in mind here we have the activation energy for the first reaction, and this is the activation energy for the second reaction. So based on that, we can notice that the second reaction here is very fast, and the first one is very slow since it has higher activation energy. And just keep in mind the intermediate, it's a species that appears within the reaction and cannot be shown after the reaction happened. Let's think about question 4, and it says the table shows the amount of energy released per gram when some alkanes are burned and excess oxygen under standard conditions. The question says, which alkane has the standard enthalpy change of combustion of negative 2877 kilojoule per mole? If you look at the table, the unit here is given in kilojoule per gram, and we need to change it from kilojoule per gram to kilojoule per mole. Technically, if we look at that in terms of a conversion factor, kilojoule per gram, should I multiply with in order to get kilojoule per mole? Obviously, we have no change in the kilojoule, but in order to get rid of the gram and substitute it with mole, we have to multiply that by gram per mole. And it's obvious that gram per mole represents the molar mass. So multiplying this magnitude with the molar mass, it will end up with a unit of kilojoule per mole. So our target is to calculate the molar mass for each one in here. This is CH4, it has a molar mass of 16. This is C2H6, it has a molar mass of 30. And we have propane, which is C3H8 with a molar mass of 44. And we have butane with a molar mass of C4H10. So it's 58 gram per mole. Now we have to try every single number from here. You have to say 55.6 times 16, 52 per times 30. We have to try 50.4 times 44 and 94.6 times 58. And if we try the first one, 55.6 times 16, it equals to 8896. No, it's not the answer. 52 times 30 is equal to 1560. No, it's not the answer. We are looking for this one. And 50.4 times 44, the answer is 2217.6. No, it's not the answer. Definitely, it's D. It's 49.6 times 58. The answer is 2867.8. So definitely it's the true answer. The answer is D. Guys, in this question, I need you to read the question carefully and then answer it with me. The question says, a student measures the enthalpy change of combustion, delta CH, of methanol, which is the fuel, using this apparatus as we can see in here. After burning 0.2 grams of methanol, the temperature of water increased by 16 degrees Celsius, and this tells us that delta C is equal to 16 in here. The measurement uncertainty and the thermometer used in this experiment is 0.5. The uncertainty means that you could have an error within this 0.5. And this is for each reading. What is the percentage uncertainty and the temperature change of 16 degrees Celsius? Just keep in mind there's a beautiful rule to be applied for the percentage uncertainty, and it's equal to uncertainty over the reading times 100. Uncertainty percentage is going to be applied on the temperature change, which means delta T. Delta T is calculated by taking the T final minus T initial. In other words, we have an uncertainty in 0.5 of T final and another uncertainty of 0.5 in the T initial. The total is equal to 0.5 times 2 equals 1 degree Celsius. And if we apply this rule in here, it's equal to 1, which is the uncertainty, over the reading, which is 16 degrees Celsius, and we multiply it by 100, it gives us 6.25%, which is C. B says, the student repeats the experiment but burns 0.2 grams of methanol and uses 75 cubic centimeter of water and the copper calorimeter. What is the expected temperature change in this experiment? You have to keep in mind that the delta T increases with increasing the fuel, and delta T decreases with increasing the water. So in this experiment, the fuel is increased. It was 0.2 grams and now it becomes 0.3 grams. So we're supposed to have delta T to increase. Okay, and for water, it was 50 cubic centimeter and now it becomes 75. Increasing the volume of water leads to decrease the temperature change. So it was 50 cubic centimeter and now it becomes 75 cubic centimeter. And delta T will decrease. Now we have to change all of these values into fractions in order to get the correct value of delta T. Since delta T increases with increasing the fuel, I have to take the fraction of the bigger number over the smaller number. It's going to be 0.3 over 0.2. And then we say multiply. The water here is increased, which means delta T will decrease. So we take the fraction of 50 cubic centimeter over 75 cubic centimeter. And then we multiply them with delta T, which is 16. And if you apply this rule, you will end up with a value of 16 degrees Celsius. Just keep in mind, if the water is decreased, I mean, it was 75 and now it turns to 50, we have to take the fraction as 75 over 50 because it has to be bigger. Delta T has to be bigger. That's why we take the big number over the smaller number. But since the delta T is decreased by increasing the volume of water, we have to take the small number over the big number. So the answer definitely is C. Let's calculate C. The students calculated the enthalpy change of combustion of methanol is more exothermic than the data booklet. What is the possible reason for this? More exothermic, it means more energy was produced. So heat loss, no, heat loss causes the delta H to decrease. In complete combustion, it also causes the delta H to decrease. Evaporation of fuel causes delta H to decrease. The last one says, use the molar mass of ethanol. Just keep in mind that delta H is equal to negative Q over N. And N here represents the fuel, the moles of a fuel. If the moles of a fuel increase, the delta H will decrease, and vice versa. If the moles decrease, the delta H will increase. The moles are equal to mass over molar mass. We have two types of alcohols. We have CH3OH and we have C2H5OH, which is ethanol. If the molar mass of ethanol, which is higher, increase, then the moles will decrease. If the moles decrease, delta H will increase for sure. So that's why the answer is D.